Welcome to this video by Cosmic Essence. I'm Atray and I teach physics and chemistry at Cosmic Essence Education. Today we're going to be discussing about electric potential with a point charge as well as a system of charges. So get your notebooks out and let's get started. Okay, so first things first, we're going to be discussing what electric potential is, and then we're going to find out electric potential of a single charge as well as for a system of charges. So first of all, what is electric potential? Electric potential is simply the potential energy of a unit charge, or in simpler terms, suppose if I have a charge over here named capital Q and this is the charge on the thing. Okay, now obviously it has an electric field around it in a spherical manner. So let's consider a point here, say R. Okay, now to bring a unit charge from infinity till this point, which has a distance of R from Q, the work done to bring it from infinity to this point at a distance of R from the charge Q, that work gets stored in the unit charge as potential energy, and we name that potential energy as electric potential because we are talking about a single unit charge. Okay, so that's why we just call, so V is equals to just UR, so V at R is equals to U at R divided by whatever charge that we are bringing. Suppose we are bringing Q charge from infinity to this point, so that will be the work that is done, that is UR divided by Q, that will give me the charge for this. Okay, so this is my electric potential at this point. Now just like potential energy, and we've discussed that in the next video, you'll find it in the link below or in the links in this video. But just like potential energy, this also works. Electric potential is also working with a concept of difference. That is, it is only relevant when there is a difference from one point to another. And obviously here we are taking that difference between point R and point infinity. Point R and point infinity. Okay, so we are saying that potential at infinity is 0 or potential energy at infinity is 0. That's why we are able to consider this. Okay, so because this is 0, we can remove it from our equations and from our description, so we can just directly write VR is equals to UR by Q. Okay, so that is extremely important to understand. Once we've understood this, what electric potential is, just to write the definition, electric potential is work done to bring a unit charge from infinity to its position. This is the work done. This is what gets stored in the object as potential energy. Okay. Now, once we've understood this and we've discussed this, let's now get on to the first thing, which is potential due to a point charge. So we have a point charge over here. We'll just use this. So suppose I have 2 points, 2 positions, S and R. My charge, the unit charge, moves from this to this. It moves from this to this, okay, and it is moving, say it has arbitrarily come to this point P, which is R dash away from S. Okay, let's understand. What am I doing? I've said that this is my charge, okay, the source charge which is creating the electric field, and I'm bringing my test charge from a position of S to a position of R. Okay, now when I'm bringing it from S to R, what's going to happen is I have to take that charge and bring it very slowly back. Why is that? Because my charge, if I bring it quickly, if I just pull it like this, what's going to happen is the charge is going to accelerate, and when the charge accelerates, it dissipates energy. That means it loses its energy, and obviously when a charge accelerates, it will gain kinetic energy rather than potential energy. So that's why when we are working against an electric field and we want to store that work done as potential energy, what we do is we pull that charge very slowly from point to point such that the work done, the force that I am applying to pull it is equal to the force by the electric force at each point. Okay, this way the charge never gets accelerated and it slowly reaches its position, and all that work done in the middle gets stored at the new position. Okay, so this is the idea. Now this charge of mine, the test charge, wants to go from S to S to R, and it has already reached an arbitrary point in the middle P, okay, which is at an R dash distance, which is at an R dash distance from S, because this is what it has moved till now. Now from R dash it moves further, say it moves a delta R dash further. Okay, it moves delta R dash further. I believe it's difficult to see, so I'll just make it again. R dash, and it moves delta R dash further. Now once I've understood this, now I will try to create the work done. So how much would be the work done? Work done is simply F dot S. Now I'm assuming that this is at a radial direction. Why can I assume that? Because the work done is a scalar quantity. That means it does not depend on the direction, on the way the work is done. Okay, that means I can pull the charge here and then bring it here and then take it back, and the amount of work that I do or the amount of potential same, and so F dot S I can put. S is obviously delta R dash that we are moving at a particular point, and F is the force on this object at this point, and that would obviously be Q, which is this source charge, into 1, because that is the test charge, upon 4 pi epsilon naught R dash square. Okay, so this is the force because that is the distance of this point. Once we have that, we'll just integrate it. Now integrating this from 0 to R dash, 0 to R, okay, or rather infinity to R, I would say infinity to R, because I'm bringing it from here, I'm bringing it from infinity till this place R. Okay, I'm bringing it from infinity to this place R. This is W. This will be equals to infinity to R Q upon 4 pi epsilon R dash square dr dash. Okay, all of this is constant, so I will take that out and I am only left with 1 upon R dash square. So 1 upon R dash square integration of 1 upon r dash square is simply minus of 1 upon r dash, and obviously I will have to put the limit of infinity to r. Okay, so it becomes minus 1 upon r dash, which I have put it like this, and obviously I have to put the limit infinity. When r dash is put as infinity, obviously this will be 0, so I will have to put it 0, and so I am only left with the total work done will be minus q upon 4 pi epsilon naught r. This is the work done to bring a a unit charge from infinity to point r, and this is the potential by a source charge q. Okay, now why is there a negative sign over here? This is very important. Why is there a negative sign over here? Because this delta r that I was taking, this is negative. I'm taking it this way, right? So remember, F dot S here will be negative. Why? Because my force is from that side. Okay, my force is from that side. Sorry, the electric force is from this side, and the movement is in the negative side. The electric force is that side because it is pushing the charge away. But my del S, which is the displacement is happening in the opposite side, and that's why the negative sign comes in. Okay, so this is extremely important to understand, and this is the potential by a single point charge. Fine. Now, once we've understood this, the system of charges is super simple. System of charges is super simple. System of charges simply implies that I have a group of charges like this, say A, B, C, and I have another charge P, and I want to find the potential of P, potential at P or off P by these charges. Very simply, what's going to happen is the electric field over here will be a sum total of the electric field by these charges. So it follows the superposition law of electric field, and that's why I can use these system of charges as a concept. So what's going to happen is the total potential I am going to do directly. The total potential is going to be, let's say this is also Q, let's say this is QA, this is QB, this is QC, this is QP. So the potential of P by A, which will be equals to QA into QP. No, this is unit charge, so I do not need to add a QP because it will confuse you. 4 pi epsilon into R. This is R. Plus, this is R2, this is R3, so this will be QB. And this simply becomes my potential at point B, potential at point P by a system of charges, which is simply following the superposition rule of electric field. And because of that, because all the electric fields combine and join, you can see all the potentials are also joining over here very simply. Okay, so it's super simple, but you have to understand that this is electric potential. If you wanted to find electric potential energy, then we will just multiply it with Q, and I'll talk about that in the next section in the next video. Thank you for watching this video. I hope you liked it. If you did, please do like, subscribe and share this video with your friends and maybe even family members, so that they can learn better and start thinking well. Okay, please do comment in the comment box below with your doubts, with your suggestions of what videos I should be making, what topics I should be covering, and I will get back to them as soon as possible in the next videos that I prepare.